righty. Anybody there? Hey, I assume you guys can see this. There we go. Can everybody see this beautiful QR code? Yes, no? Nobody sees it? Can anybody say
Yes, I see.
16,000 baht? Let's check your microphones. 16,000 baht. Right? Per day, every day of the year, 16,000 baht, almost $500 a day. Somebody's going to just give you $500 cash every day. Will you take it? Are you happy? 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 Will you study? Don't know. Either they don't like money director, or their microphones aren't working, or they're sleeping. So why do we study? Why do we go to school? Why do you study to be an aircraft engineer? You could have been a doctor, could have been a lawyer. Ah, she says I need to hit something to make it a group call here. I think maybe we have this working. So anyhow, I assume you guys can hear me? Yes, no?
Yes, we can hear you.
You can hear me. 16,000 baht. Can you say 16,000 baht? 16,000 baht. Anus. Can you say 16,000 baht? 16,000 baht. Mr. Panus. 16,000 baht. Can he say it? Nope. Yep, no. Okay. Point is, you guys are all studying to be aircraft engineers. Maybe your parents said, oh, you should go to CATC. Maybe you thought it was a good idea. Perhaps somebody else thought it was a good idea. But in the end, we study not to make the director happy, certainly not to make me happy. Don't study to make me happy. Study to make yourself happy. You got to find your happiness. So back when I was a kid, I used to want to be a pilot. I wanted to fly 747, Boeing 747. It's just such an amazing airplane. Now I'm going to be studying at home. While you guys are studying, I will be studying. I will be taking school on Boeing 747. I will be a flight mechanic. I will fly with Cargo 747. And if I do not take a vacation, I will get paid every day of the year. $485, 16,000 baht every day. If I fly, if I don't fly. Basically, if I'm on duty, they give me 16,000 baht every day. So it's good to know how to study. I have a problem. I used to work on 747s a very, very long time ago. 1992 until about 1997. I don't think I've really seen a 747 since then. We had one come to my gate in Newark In 11 years of being at Newark, I think I only worked 747 one time. So now I'm going to be working on the airplane. America, we don't get training like you guys. You guys get hired, you'll go to a job and they'll say, oh, you work with this old guy, he'll teach you. Maybe the old guy is all 28 years old, 30, really old, crusty. So they'll teach you. But in America, they say, hey, you've got your license, that's your airplane, you fix it. Oh, yeah, some experience on 747, but there are going to be a lot of things that are going to break that I'll have to say, ooh, I haven't seen that problem before. But I'm the only mechanic, and maybe I'm stuck somewhere I do not want to be. Maybe I'm in Afghanistan, and I don't want to stay in Afghanistan, so I have to fix the plane. So basically then, planes are planes, and we use ATA specifications. Technically, they've changed it. There's something now called iSpec 2000 and iSpec 2200. But basically, we're still doing the same thing. We want to fix something in the aircraft maintenance manual. We look at our manual breakdown, general arrangement, how to use the manual breakdown. This is the aircraft maintenance manual from A320. You notice A319, A320, A321. This one's probably from Indian Airlines, possibly. This is the front matter of the manual, ATA 00. I notice, Mr. Director, we do not have an echo. I don't hear an echo, so I'm not sure if you can hear me. Am I transmitting? Perhaps. Can anybody hear me? Can anybody say 16,000 bucks? Good. Okay, I can hear that you guys can hear me. All right. So basically, I'm going to have the 747-400, and I'm going to go out to the airplane, going to go fly on this airplane around the world as a mechanic. And I haven't worked on a real airplane in 7 years. And things will break. And this is why you don't work from memory. It's always good to say, well, I have a computer here, and I've got a program called Boeing Toolbox, and it has all of the manuals that I need for 767, 747. I can go in there, and if I remember how to use the maintenance manual from the 757, then I can figure out where on the 747 I can find the information I need. So Lufthansa put together this little training program here where they explain how you would use maintenance manuals, how training books are written up. As they go through, they've got different pages here that they talk about. Like they use an example of this page manual breakdown, and it's kind of hard to read it. It's very blurred. It's not very well done. Back in probably the 1990s, they made this. Basically, with this book, all they did is they took the front part of Airbus's maintenance manual. So in ATA 00, which is your introduction, every manual you're going to use is going to have ATA 00 introduction. So if you're working Boeing 737 with a fault isolation manual and you don't know how to use the manual, you will go to ATA 00 and you can read it. It will explain how they wrote the manual, how they break things down. They will help you so that you can find the information and you can work on the airplane. So the data contained in the aircraft maintenance manual will be established in general compliance with ATA specification 2200, iSpec 2200. Previous version of this manual that I had in lectures, it would say that it's in accordance with ATA specifications, and then it mentions this ATA iSpec 2200. This is a new specification that came out because we're going to a world where more of the manuals are not in paper format anymore. They're not on microfilm, but now they're going to be documents that are created as if it was a web page. So they're not making a document so much anymore as they're making things that function more like your internet experience. Makes the layout of the books change. Things look different. One thing I'll caution you on, though, is Airbus is very careless about where they break a sentence or end a paragraph or where they put information. It's quite common with Airbus that you might think that you have read all the way through to the end of the section that applies to you and you stop reading. You should go through the entire section all the way to the end and make sure that they haven't snuck in part of a paragraph or a sentence somewhere else that really should have been all put on one page. If you were going to print the book, you would put everything in one page. If you had to go to a second page, then you might put at the bottom a note saying continued on next page. Airbus doesn't do this. And quite often they'll put a picture right in the middle of your text and continue your instructions after the picture. And you may never actually notice that extra part that's in there and you'll miss important information. So this iSpec 2200, you go to a job interview and you say that you know ATA specifications. You might have some people say, well, ATA doesn't exist anymore. It's actually, they've changed the name. It's now called A4A, alpha, the number 4, the letter alpha. So A4A is now the organization. ATA as an organization doesn't exist anymore. So technically people are right, but if you say chapter 38 on all your airplanes will be water and waste. It will be the same on every aircraft. So if I'm working the Boeing 747-400 and I have an autopilot problem, go up to the cockpit and I see, yes, indeed, the pilot does have a problem. One of the autopilot systems, it's just not working. 3 autopilots on the 747-400 require 2 of them to dispatch the airplane legally. You have to verify that the aircraft is not in a single source configuration. You have to verify that at least both of your autopilots are working, but you're not actually flying off of an airplane with only one operating autopilot. So in your aircraft maintenance manual, you're going to find information that tells you about servicing, repair, replacing, adjusting, inspecting and checking of equipment. You can also find information on cleaning and painting. These will all be broken down into separate page blocks, different page blocks of your manual system. Page blocks are important to watch because you might think that you have the correct part of your manual, but you're not actually in the correct page block. We're here in page block 1. Something in page block 1 will not describe how to service a component, how to inspect it, how to repair the component. This just describes general information that covers things that are in that chapter. Chapter 00 is introduction, also called front matter. So ATA 0 will not give us any instructions on how to actually fix anything. It just tells us how the book is laid out. All of your aircraft models will have a CMM, Component Maintenance Manual. Airbus likes to call them Component Maintenance Manual Vendor or Component Maintenance Manufacturer, CMMM or CMMV. Boeing, it will just be called CMM, regardless, whether it's vendor or manufacturer. Here's an important thing to remember. A lot of even very experienced inspectors and structural repair mechanics forget this. The aircraft maintenance manual also contains information about inspections and maintenance of aircraft structure. So you don't always find all of your information in your structural repair manual. So structural repair manual would be one that you would use to perform repairs, but sometimes you also, in both the Boeing and the Airbus, you also have to refer to your chapter 51 or 53. 1 is just general things about aircraft structure. 3 is aircraft fuselage. If you're a QC inspector like I was, you wouldn't be limited only to information and data from the structural repair manual. There's also a lot of times you would have to look at both the SRM and the AMM, both for things on, say, fuselage on ATA 53. Airbus likes to have nacelle structural repair manuals. Boeing doesn't do this, as far as I know, that they call something a nacelle structural repair manual. In a Boeing aircraft, that would just be called a component maintenance manual, because your nacelles, things like your thrust reverser sleeves on the outside, the entire thrust reverser assembly, your inlet duct for the engine, these things are usually manufactured by somebody other than Boeing or Airbus, so then they have their own publications. E.F. Goodrich is one company, maybe you've heard of the tires, but they also make nacelles for the A320. So I have an A320 nacelle structural repair manual for the CFM56 engine on A320, and then one for the V2500 engine on A320. A320, you have several options for engines. The manuals that I have cover 2 of those engine types. 737 has only one choice of engine supplier for the series that will cover, the 737-800 series. Maintenance Review Board Report. This is senior quality control and maintenance planning people at the airlines will get together. Different companies will all get together with the manufacturer, sometimes with people like FAA, and they'll discuss things that tend to break often or perhaps should be inspected at different time periods and intervals. And they help to write your maintenance manual and your maintenance program. If you're very, very senior, even more senior than me, and I've got over 30 years of experience with a license, you'll find that a lot of these people are very, very top people in quality control and in maintenance, and they try to figure out things that perhaps maybe they should be inspected more frequently or less frequently, and they're the ones that help to do your maintenance planning in terms of what you're going to look at. Master Minimum Equipment List, MMEL. If you go to work at any of your airlines here in Thailand, your airlines are big enough that most of you probably won't use the Master Minimum Equipment List. This is something like the FAA puts this out to say that these are the things that are on an aircraft. Certain number of things have to be operational for dispatch. So autopilot, if you have 3 autopilots, you need to have at least 2 operating for dispatch. So that would be covered under your minimum equipment list. Your airlines most likely will just call it MEL, minimum equipment list. Configuration deviation list covers things that are missing from the aircraft. Like if you have a fuel truck, it's a flat track fairing, those are composite, it gets crushed and damaged. You can remove that from the aircraft, send it to some place to get it overhauled. You can go fly the airplane with this component missing, completely missing from the aircraft. You've deviated from your configuration. So there'll be a time limit, how long you'll be allowed to fly the aircraft, and then also you will have a penalty. You'll be burning more fuel. So you have to change that in the flight management computer on the 737. There's a fuel penalty index, cost index. You can change that, and it'll tell the computer that you're burning more fuel than usually you'd be burning otherwise. There'd be a time limit on maintenance items covered under the minimum equipment list. You may be limited to 1 flight with something enough. You might be allowed 3 days, 1 day, 3 days, 7 days, 10 days. Depends on the item and the airline. That you can fly with this one component that's not working. Eventually, you have to fix it. The 737 that just crashed in Indonesia, they had first officer's airspeed indicator was on MEL. It was INOP, so the first officer's airspeed indicator was known to be not working.
Anthony,
and their auto throttles also. Yes?
excuse me, can you share the screen, please? So we can catch where you at.
Let's see, where
I only see the QR code here.
Use our screen. I hit stop sharing. Let me share it again here. See, got that one? How's that?
Oh yeah, okay, it's working now. Thank you.
Yeah, thanks, because I have no way to know if you can see anything. Do this to here. Watermark. If you guys get a document that has a watermark, this one has a document that says training only across it right here. very faint. You can barely see it. Training only right there. And that's causing some trouble. Watermark, you can hit this, remove. You can remove watermarks. So if you buy a document from somebody, or you get it off the internet and you don't want it to have the watermark, you can remove it. You can also add watermarks. I want to put this one watermark back on again. This is a good disclaimer to have. All right, so that's a bit better. So keep in mind that these manuals that we're using in the class are for technical English training only. Do not use for actual maintenance on aircraft. Reason being is sometimes I can go in and I can change the text. So if I've done that in some places, which I did heavily on the Boeing manuals, by the way, there's a lot of things in the manual where I've gone in and changed what it said, and you may not find that information is correct anymore. And some of that was done on purpose so that we could have some training material that kind of fit a little bit better than what the original version said. Okay, so if you see this R right here, there's an R as in Romeo right here. This indicates that this part of this page was revised. So in this case here, they have aircraft here in their effectivity chart, Indian Airlines. They've got this serial number 3551, 3620, 3687. At the time that they did this manual, they probably still were on the factory production line. They just ordered this airplane. It has not been registered yet. These three aircraft do not have registrations. They're not actively flying yet, so they may still be in the factory floor being produced. And then this is May 1st of 2008. That's the date that this page was effective. That's the revision date. Revision date. Effectivity. Effectivity is a strange sounding word. It's only used in aviation. Effectivity. If I'm working on aircraft, what airplane numbers do they use here? Customer fleet serial number. So they'll say 902. You might be working on 902, but at this time in 2008, you wouldn't be working on aircraft 907 or 908 or 909 because they're not registered yet. This airplane here was nice and new back then, aircraft 906. Notice that that has nothing to do with the serial number of the airplane or the registration. Continental was nice to us. If we had an effectivity number of 906, then if we looked at our registration number, the last three numbers in our registration numbers would be 906. They would arrange with the FAA to get a registration number that always had the last three numbers to match our fleet effectivity. So if you didn't know what airplane effectivity you had, you could just look at the airplane and say, oh, we're working on 021. United Airlines, they use 4-digit effectivity numbers and they paint those on the nose gear door. And sometimes United's numbers don't really correlate to anything logical. So that's the way if you're working on United Airlines airplane, you have to look at the nose gear door. So continuing on. Now this is boring, but this will help you. You will understand when you're doing a project on something, you'll understand how and where to look for the information. Or in my case, when I'm making 16,000 baht every day, they'll come to me and they'll remind me, hey, and we're not engineers in America, we're just grease monkey. Yeah, grease monkey. Hey, when are you gonna fix my plane? I want to go fly. They want quick cargo flight. They're making lots of money. Medical supplies. A lot of this stuff is sensitive. If I have an airplane full of vaccines, that needs to go. It can't sit on the ramp in hot temperatures. This stuff might, spoil and expire. So auto flight, yeah, captain says his auto is he has a problem with his autopilot. So autopilot would be ATA Chapter 22. Every airplane, Airbus, Canadair, Antonov, anybody, the Caravelle, even the Caravelle books. If we take the Caravelle manual back in 1964, they already had this system. You take the Caravelle manual and we look at the bottom of this very dusty page, ATA, it says 51-6-1, which is interesting to see because you have the 2-digit number for the ATA chapter, followed by a -1 and the -6. In Boeing and Airbus, they'll say 01 and 06. They'll add the numbers in. But Douglas and Sud Aviation, I noticed in their manuals that the first 2 digits of your ATA code will always be 2 numbers. Sometimes in their subsystem breakdowns, they only use single digits for their ATA. Fuel system, ATA 28. On the 747, if I go to a military base, I'm in a civilian aircraft. The U.S. military, maybe they're sending troops somewhere, they charter the aircraft. Their fuel truck operator will only operate the fuel truck. He will not touch the fuel hose. He will not install the fuel hose onto the aircraft. He will not operate the fueling panel. It'll be my responsibility to drag the hose up, hook it up to the airplane, and then I have to put the fuel into the tanks. He'll turn the pump on the truck on. I have to control which tank I'm going to put the fuel in and make sure that my fuel load matches what I want for dispatch. However, the process on how to fuel, how do I fuel a Boeing 747-400? Oh, do I look in ATA 28? Hydraulics, do I look in ATA hydraulics? Oh, I want to add hydraulic fluid to the reservoir. ATA 29, how's hydraulics? Landing gear, I want to service landing gear. Need to put nitrogen in the landing gear strut or hydraulic fluid. I want to put air in the tire. Air in the tire. By the way, don't put air in tires on commercial airplanes. Completely illegal. They had a fire many, many thousands of years ago. They had a fire with a landing gear, a tire caught fire. So now you can only service your main landing gear wheels, your main landing gear tires on commercial aircraft with pure nitrogen. There's a strict limitations on the oxygen content, and it's about like 0.1% oxygen. Basically, they want no oxygen in a tire. So now we've mentioned all these systems, but we're servicing. This is the question. How do I service the fuel? How do I service the toilet system? Oh, ATA 38. Glad I don't do that. That's dangerous. ATA 12, servicing, ATA 12. Most of the GenFam tasks that I have on the folders, put the links on Facebook, you guys can download them. Most of those tasks are from ATA 12, from servicing. How do you add oil to the engine? How do you even clean cockpit windows? How do you do these things? It's in ATA 12. So it's important to know your manual breakdown. What chapter will you go to? Somebody asked me earlier, because they looked through this and they said, teacher, where's 37? Where's ATA 37? Very interesting that he saw this. There is no vacuum, ATA 37, on Boeing aircraft. We don't have a need for vacuum systems. Some older instruments, some older systems, you had to have a vacuum pump, mechanical pump, turned by the engine, create a vacuum pressure. On these commercial aircraft, we don't have any ATA 37. So you won't find 37 in Boeing or Airbus aircraft. Most aircraft will have a 71 and a 72, both A320 and 737. Follow a pretty good logical approach in terms of what things go in 71, what things go in 72. The actual basic engine that you have, without the thrust reversers, without the cowling. Those things will be in ATA 72. The things that are outside of the actual engine that you would lease from the company, things that are more attached to the aircraft itself, things like the cowling. These things will be where they would put into ATA 71. Standard practices, you notice it's 70. Standard practices engines. If you have something, maybe it's not covered in 72, check your ATA 70. Things like torques. How do you use safety wire? What lock wire procedures do you have? What kind of safety wire can you use on an engine? At General Electric, when I overhauled the engines, we used a completely different safety wire than what you use on airplanes. We used something that was very, very soft. And we were not supposed to use safety wire pliers. We were supposed to turn everything by hand, pull it through gently, try not to make any scratches. It was a very, very soft wire. You guys are using the stainless steel wire, which is much more tough. Standard practice is airframe, ATA 20. So a lot of the things that you would do on the airframe that are common tasks, these would be in ATA 20. Any questions? Anybody awake? So within your chapters, you'll have a breakdown of things where, like, ATA 29 is your hydraulics, general. ATA 2910 is main hydraulic power. ATA 29-20 is auxiliary hydraulic power. So they have things called ram air turbines, like a backup source of auxiliary hydraulic power. That would be here. To open a cargo door in a A320, there's a small little electric pump that will only operate a hydraulic system, so you can open the cargo door. I would imagine, if I needed to look for that, I would look in 2920 first. I don't think that would be under 2910. So 2910 itself then breaks down into 2911 for green, main hydraulic power. ATA 2912 is blue, main hydraulic power. #1 engine. On most Airbus aircraft, you're going to have pumps on both engines. A320 is a little different though, but A320 we do have an engine-driven pump. Green main hydraulic power. A300s, we had 2 pumps on green system, #1 engine. We had 2 engine-driven pumps on blue system. And then yellow system, sorry, we had 1 pump for green, 1 pump for blue. We had 2 pumps for yellow system on A300. A320 doesn't do that. They use something called a power transfer unit. And then they have the 1 engine-driven pump. We'll deal with that later because that's a little more difficult to explain. This is just how you use the manual system. But I know there's probably at least one person out there who's know how this Airbus system works, but it's A320 is a weird airplane hydraulically. 2910 broken down into 2911, 2912, 2913. Then each one of these tasks, if you look at our 2911, then we'll break down even further into more specific things. 291114, 291115, 291132. Now, what you don't want to do is you don't want to have a little book or little sheet that you'll walk around with and you'll say, oh, I've got this nice 747-400 sheet book. Oh, and it's got lists of, ATA 32, 4511, remove and replace main landing gear. That's easy. I don't need to read the manual. I've been working on these airplanes since 1992. I don't need to read the manual. 550 foot-pounds torque, back it off to 0, and then retorque it again to 110 foot-pounds, and then put the nut in. Work from memory, not good, not good. Maybe you might look and say, oh, 291114, use this maybe to help remind you, but always go every day, do the same thing every day. Still go to your control legal document within your company's system. If it's a laptop, you're going online, always make sure that you're using the current revision. This manual is February 1st of 1996. A lot of things have happened since 1996. Maybe the information is different. So you don't want to work from memory, because we've had cases where people have gone and signed things using their cheat sheets. And then they'll have specific task numbers that that will have changed. And they sign off using an out-of-date reference, and then they end up in trouble because they didn't actually use the manual. So you're also in Airbus, Boeing, you're going to have standard practices manual. For Airbus, they just have one standard practices manual. For the airframe, then they have an electrical standard practices manual. Boeing will have a standard wiring practices manual, and then a standard overhaul practices manual. Now, standard overhaul practices, you would think that doesn't apply because I'm on the flight line and it's a through flight. But still, a lot of Boeing manuals will refer you to go to the SOPM. If you're going to repair, let's say, a cabin floorboard has a fault, you need to do a patch. It may refer you to the standard overhaul practices manual. In the cell structures repair manual, like I said, this is a component maintenance manual that the manufacturers of the actual engine nacelles will publish. It's not an Airbus manual, but it's part of the Airbus system. Usually Airbus just puts a small introductory page at the front, and then after that, you'll find it through in the D.F. Goodrich manual. But effectivity table. You will want to make sure that your aircraft fleet number, you're using your correct effectivity. So in this case, they say the aircraft identified by an Airbus manufacturer serial number in the effectivity table is covered in the AMM. So you would not want to use some of the manuals that I've given you guys that you can download and you can read for fun. You don't want to use one of these manuals to work on an airplane from a different airline, because a lot of times some of the options that were available for Continental Airlines may not have been available for the airplanes that went, let's say, to China Southern. And then things like torques may be completely different. So for Indian Airlines, you can see there's going to be a big difference between aircraft 14, which is in this block, and aircraft 901. Aircraft 14 is an A320. Aircraft 901 is an A319. Different size airplane, but also completely different engines. CFM56, this is the same type of engine that you're going to find on your 737-800 series aircraft. The 737 uses a CFM56-7B. The Scarebus uses a CFM56-5. Indian Airlines with their A320s, A320-231 series, they're using the V2500. This is an engine that's made by an international consortium. One of the biggest manufacturers that's part of this organization is Pratt & Whitney. You guys know Pratt & Whitney from your T6 engine. CFM56 is General Electric in partnership with some French companies. There's a company called Snecma. They developed this engine together. And I believe Snecma has changed their name. They're called something else now. But basically, you have like a GE engine and the Pratt & Whitney engine, almost whatever it is. But CFM International and IAE V2500. Two engine choices on the A320s we will talk about. If you get some of the newer A320s, then they have more engine options altogether. There's an A320 Neo, which I don't have manuals for, and that uses a Pratt & Whitney engine. So you guys are all smart. Nobody's asking any questions, so I'm sure that you're all experts on how to use manuals. in this document right here, February 1st of 2007, you'll notice that there are all of these R's here. What do these R? Pirate movies, they all say R. Pirates of the Caribbean, R. R, matey. Gotta watch the R's. The R means revision. Something has been revised. In the case of this particular page in 2007, I would guarantee that all of these are actually not things that have changed, but they have completely added all of these sentences that are here. So they're saying specific features for the AMM and AirNav/maintenance environment. They give out DVDs. We have some of these upstairs in our library, where the entire set of manuals for this airplane is now provided in the digital environment on DVD in something called AirNav. And then Airbus would then issue out other DVDs with temporary revisions that somehow would either just be viewed separately, which is what I suspect, or they could actually come in and patch like an update and change the data. We have these discs upstairs for A330, A340, but unfortunately we no longer have Windows XP. I think Windows XP was the most advanced computer system that would operate these disks. So I've tried to get some of these to run, but they don't. So with Indian Airlines, they were just starting to get the digital manuals when this came out. This actual manual that they use, because this was originally, I think, Indian Airlines, they basically were a PDF document. Some of them very obviously were paper books that they put through a scanner and scanned in paper format. So these R's indicate something has changed in the manual. Most often you're going to find that basically something in the sentence changed, but in this case, on this page, it's a little bit special because I can pretty much guarantee that almost all of this, this was a brand new paragraph. And then these other pages, sections of the page down here got changed because they're affected by the fact that there are now these DVDs. Effectivity. Effectivity means that this manual covers all aircraft that are operated by this airline. Down here, normally, it would have a 3-letter code identifying the airline. And I think it was IAC for Indian Airlines. But I edited it out because this is for training only. That one anymore. Let's get to that one. All righty. So in our previous So for those of you who have seen an Airbus A320, you will recognize this. There are 4 main landing gear wheels. Each wheel has a brake inside of it. There are no hydraulic brakes on the nose wheels. However, Boeing 727, they actually had brakes in the nose wheels on some aircraft. I just saw that the other day for the first time on the internet. That 727 that this guy was operating, they had brakes in the nose wheels as well as the main. So most of you guys, when you see your 730 or your A320s at the airport, you're going to only have 2 wheels on each axle. Each of these components is identified by an FIN, functional item number. Oh, look at what it was again. So right here, this 2650GM, this code, this functional identification code, is used in every manual: IPC, troubleshooting manual, wiring diagram manual, system schematic manual. All of these manuals across the entire system will use this number. So if I had a computer with my Boeing toolbox inside of it, we had 8 Airbus airplanes put into that, you could find these numbers. Boeing uses a similar system, and I could type in that number and it will cross-reference every time that that item is referred to in every manual across the entire fleet. This will greatly help troubleshooting. I can go through, I think I'll have 11 different manuals that cover different parts of the Boeing 747, but with these identifying numbers, it'll pull up all of the suggested things I should look at across every single manual system. So with this picture here, we have 4 main landing gear wheels. At the bottom of the page, we will notice that our airline effectivity is CES. I believe this is China Eastern Airlines. So in China Eastern, from aircraft 01 through 49, 101 through 149, this particular figure, this particular picture covers those aircraft. Airbus, you have to be very careful because this says configuration 1. Since configuration 1 is the first thing you'll see in the manual, you might read this section of 324111 and remove and install your main gear wheel and tire assembly in accordance with whatever the instructions are. But your airplane might have been modified. Maybe you're working on aircraft 051 and, oh, 051 is not covered by this effectivity. Maybe it has configuration 2, configuration 3. What might happen is they may decide that these wheels will have a brake assembly inside, and the brakes are very, very heavy. There are companies now that are coming out with carbon disc brakes, composite type brakes, that they're much lighter. And if you change all 4 of them, the savings that you'll have in terms of how much fuel you burn is incredible. So sorry, they have carbon brakes. And carbon brakes are quite a lot lighter, about 50 pounds each. 50-pound change in a 45-pound change in a 757-200 about 20 years ago was $15,000 that you'd save every year in fuel burn on each airplane. So effectivity is important because we'd have to know what configuration aircraft we're working on and have our manuals reflect that. We don't want to use manuals from a different airline because maybe the information is not the same. And I will show you an example of this. We have extra music in the background for there we go. Can you see this, engineers? Yes? No? No, you can't see this?
Yes, I have seen it.
Okay, now you notice maybe it's hard to see, but you notice the letters don't look quite so clear, a little bit more fuzzy. This is IAC. So this is Indian Airlines. Previously, we were looking at CES, China Echo Sierra. If we were working on Thai Smile, it might say Tango India TII or TYS. And I can't remember which. Boeing and Airbus, somebody uses TII, somebody uses TYS. So if you're working on an airplane that came from Indian Airlines, IAC would be what you'd want to see down here. Effectivity. Indians are superstitious. They're following the British superstition. British Airlines, you're not going to have, in Britain, you're not going to have an aircraft 13. Passengers won't fly in it. If they see 13, they'll be scared, they'll run away. I have seen an aircraft 13, I think at Continental Express. I think we had an aircraft 13, but a lot of airlines will skip the number. So any aircraft from 1 through 12, 14 through 99 is covered by this effectivity. So we have to watch for the airline, the actual airplane type, the configuration. This one's configuration 1. Configuration 1 has popped up again. But I guarantee you, this configuration 1 on this manual is going to be a lot different from the configuration 1 wheel and tire assembly on the other airplane. Even though it still says 324111, configuration 1, I guarantee that between these airlines, there's a huge difference. Our functional numbers for our main landing gear wheel, we have 8 numbers. But we only had 4 wheels on the other airplane. Why are there 8 functional identification numbers? And this is why effectivity can be very important. You want to make sure that you have the correct manual for the correct type of airplane, because this Airbus has got 8 main landing gear wheel and tire assemblies, each with a different FIN. Indian Airlines wanted this option from Airbus. They're the only customer that I know of that purchased it, where each landing gear has got 4 wheels. Everybody else has 2 wheels. I hate Airbus A320 main landing gear wheel and tires, because here in Thailand, you'll have friends. You'll work, maybe 4 people will change a tire and wheel assembly together. In America, you don't have friends. You have a tire or brake to change, your friends disappear, they vanish. Suddenly you find out nobody loves you anymore, and you have to change this wheel and tire assembly alone. This tall. The wheel and tire assembly on this airplane weighs almost twice what any of you weigh. It is extremely heavy. It is big, it's bulky, it's very hard to change. This is almost as bad as a 747 wheel and tire assembly. So for this aircraft, it'd be nice because it's a little bit easier to change the wheel and tire. But they designed it this way because there's less PSI, less pounds per square inch on your runway surface. So this airplane can go to a lot of airports in India that don't really have the money to upgrade their runways, and the larger, heavier wheel and tire assemblies will put too much pressure on the runways and possibly crack them or damage the taxiways. So Indian Airlines has some of these aircraft to send to some of these smaller communities so they can have good, reliable jet service. But then these aircraft will have less of an opportunity to do something like break through the top of the runway surface. So effectivity is very important. You have to be very careful that you have the correct effectivity for your airplane. Make sure you're using the right airlines manuals. Upstairs in our library, we have boxes of discs, and I could see that Garuda International Airlines at the time in 2007, 2008, they had 737s that had come from General Electric Capital. They had 737s from Virgin. They had a Bavarian airline that had surplused off some airplanes. So they had 737s that had come from many different original sources and owners. So you'd have to watch out to make sure you're using the correct version of the manual. So I think you guys understand that part so far. So let's look a bit at some more manuals. Important thing about tires and brakes, changing the wheels, is when you torque the nut, torque this big nut that holds the wheel on. 737-800, you take this and you tighten it to 550 foot-pounds. Second technician is going to have to rotate the wheel. They're going to push on the tire, they're going to rotate the wheel. This keeps the bearings moving nice and freely while you take the nut and try to get it to seat everything nicely. So it seats everything in there, 550 foot-pounds. You stop rotating the wheel, and you take the wrench and you put it on the other side and you push downward. 550 foot-pounds. For me to take the torque wrench and push all the way down to achieve 550 foot-pounds of torque, I'm not too skinny, but still, it takes all of my force to actually get 550 foot-pounds of torque. 600 foot-pounds of torque on some of the engine hardware, I used to have an extremely difficult time in being able to achieve it. So 550, torque it, then you back this nut back to 0 foot-pounds. Then you tighten it again to 110 foot-pounds. You line up the slots so you can install this nut that's here. You put the bolt through with nuts. I notice these ones have cotter pins. This is very good because then these nuts won't come off. When you work on Boeing 737s, always change the nut. Always change the nut because they have self-locking nuts. So 737 came into the airport when I was working for General Electric, and it was missing a wheel. The entire wheel fell off the airplane. These little bolts are the only thing keeping your wheel from falling off. 110 foot-pound of torque. If the wheel's spinning in a direction that's going to the left, your wheel's on the axle and it spins this way, it'll back your nut off. So you want to make sure that after you torque it, when you put these two bolts, these small nuts here, if you're working on the Boeing 737, you want to use new self-locking nuts. NAS 679A4, I think is the part number. You should have them in a bin somewhere in the shop. Grab a handful, keep a couple in your tool bag, and throw the old nuts away, change them, put new nuts on there. But effectivity is very important because we used to have people that would go out and change wheels and tires on MD-80 aircraft, and they would torque just from memory. Then we got some airplanes from Alaska Airlines, and we had wheels stop spinning and tires explode. And they determined the mechanics were torquing to 150 foot-pounds. And there were some wheel and tire assemblies at Alaska Airlines that the final torque was about 55, 60 foot-pounds. So about half of what the torque is on the Continental effectivity. So this was causing the wheel bearings to freeze up. The wheels would stop spinning, the tires would explode. And then when this happens, you damage the flaps, you damage landing gear door structure, all kinds of fun stuff. And then the FAA finally gets a little bit upset because if the tire explodes in an MD-80, then the bits and pieces, they get sucked into the engines and it gets expensive after a while. Can anybody say 16,000 bucks? Can anybody say what time break is? When's break time? Can anybody hear me? I think I'm talking to myself.
I'm still here.
What time is break?
I don't know.
See, going from memory, I think it's 2:10, but if I go from memory, maybe you guys don't get break when you need break. Let me refer to the manual. It says, yes, we have a break at 2:10. Most of you guys can see Facebook. I added on Facebook Boeing 737 and Airbus A320 tasks. You can download these as a zip file from Google Drive. And I tried to pick maintenance tasks that if you go to the airlines and you work there maybe 5 years on A320 or 737, I tried to pick things that during that 5-year time, you're going to do this task, maybe every day. Some of this stuff you might do very frequently. Other things, maybe you do it once or twice here and there, but I tried to pick things out, something from each ATA to the whole chapter, to the whole, the whole system of chapters. so you guys would find things that are useful to you. So if we want to service oil, ATA, what ATA would we use for oil? Engine oil, ATA. ATA 39. ATA 39 for engine oil servicing. What do you think? Anybody? Mistake I made this morning. I said ATA 39. There is no ATA 39. There's ATA 79 for engine oil. Very, very interesting. There we go. So maybe you guys have added oil. You put oil in an airplane before? Sometimes, maybe, yes, no. ATA-79 would be engine oil. ATA-24 is electrical system. Airbus has this, electrical power servicing. ATA-12, adding oil to the electrical system. What could they possibly be talking about? What do you think, Director? We have to add oil to the electrical system on the Airbus. ATA-12 has got electrical servicing. In chapter 12, electrical power servicing, adding oil to the electrical system. We are adding oil to the integral drive generator, IDG, integral drive generator. These things are heavy, but they're useful. They generate electricity. Without them, you cannot fly the airplane. You need to have your generators. So you might have to fill your integral drive generator with oil. Notice this subtask 12, 13, 24. If you just signed off your maintenance manual saying, yeah, I serviced the IDG oil in accordance with 12, 13, 24 AMM. That's very vague. It's very general, not very specific. If you're very specific and you say you serviced it in accordance with subtask 12, 13, 24, 864, 058-A, you'll want to make sure that you did everything that's in there precisely and that you read this task. You don't want to use your cheat book and say, oh, IDG oil, we service it 12, 13, 24, 864, 058A. Okay, and you just signed the logbook using the little cheat book that you keep in your pocket, never look at the manual? Because Airbus has a fun tendency, Boeing as well, 787 is even worse. That these subtasks, if there's a major revision, they will completely change the last three numbers. So your subtask all of a sudden might be 942 instead of 058A. And then your government inspectors or your quality assurance department might see, oh, people keep signing off servicing the oil in accordance with the subtask we got rid of months ago or years ago. So cheat sheets. It's not about having the right answer to the exam question. When I'm out flying on a 747 over the middle of the Pacific, 45,000 feet in the middle of the night, it wasn't about whether I got the right answer. It's about whether I was right 100% of the time about everything I did. So here we have warning, caution. Wait a minute here. We have this QR code. You can scan this. Maybe, maybe not. You can scan that and you can download the maintenance tasks for the A320. Can everybody see this?
Yes, we can see.
Good. So you guys can download these items so you can have them on your computer. Okay, here we have oxygen servicing. You'll notice that we have a different airplane type. You'll notice too here that it says this number right here, D633A101-training. Usually this word here, training, this does not exist in any of the Boeing versions of this manual. It would say CAL or UAL or CAT or TII. Your effectivity block also will not say training. It would say all, or you'd have numbers for your aircraft. You notice here that they give references for the illustrated parts catalog, and they give an effectivity. So here, if you had aircraft 209, this reference for the IPC would be not effective. 209 would be here. So we'd have to look at this illustrated parts catalog to be able to know which oxygen cylinder we would need for the airplane. The reason I mention this is because there are 3 different types of oxygen cylinder that we can use on a 737. All 3 of them will fit without any modification or change to the airplane, but they're all 3 cylinders are different. And they do the same job, but they are different part numbers. So right here, you'd want to watch this note. This is a very important thing to note right here. So shutoff valve on the 801307-00 steel cylinder is fully open at about 6.5 revolutions. Shutoff valve on this composite cylinder fully open at about 4¼ revolutions. Shutoff valve on this part number of cylinder is fully open at 6½ revolutions. If you use a different cylinder, you would need to change the weight and balance record for the aircraft. So it would be illegal if you had a composite cylinder to dispatch the airplane with a steel cylinder without updating your weight and balance on the airplane. Then your airplane would be flying illegally. So this is an important thing to note. But one of the most important things to note is how many revolutions it takes to open the cylinder. So why don't you guys take a break? Take a break. Everybody there, take a break? Yes, no. Wake up, take a break, go back to sleep.
When will we resume, teacher?
Sorry?
When will we resume?
Take a break for 20 minutes.
Okay.
เฮ้ยเอาหายไปแอนโทนี่หายไปไหนวะ
อะไรนะฮัลโหล
ไม่มีอะไรครับผม
แอนโทนีหายไปใช่ไหม
ทีมฟอนเทน
ว่ะแอนโทนีหายไปไหนอ่ะ
เขาก็มาจ้าเดี๋ยวเขาก็มา
เอาจริงเหรอ อ๋อ
ยังไม่
กำลังหาโอกาส
Can everybody see the manual?
Yeah, we can see the screen.
Okay, good. And also, I moved upstairs, so unfortunately, I lost the last lecture. Sorry, you guys had to wait at a long break. Anyway, this is one of the more important things to remember because this is something that is very easy to do wrong. So can you see what I'm doing right here? Can you see what I'm doing? Seems pretty simple, right? Yes? What am I doing? Anybody? If I wasn't wet, it would help. Anybody? 1, 2, 3? Yeah. What am I doing? Anybody? Somebody? What am I doing here? What did I just do? That was pretty simple, right? It broke, it opened, got tight at a certain point, and then snapped. It broke the ring, and this came off, right? Anybody do welding? You guys did some welding down in the shop? Yes? No? Don't all
Yes.
speak at once? Yeah. When you go to the top of the cylinder, you rotate the cylinder, and then it stops rotating. This one here, though, I turn it, it gets tight, and it doesn't snap. And then it gets loose again, and then it spins. It's tight, doesn't snap. This feels just like some of the oxygen bottles on the 737. You have some of the oxygen cylinders that you'll go and you'll rotate the shutoff valve, and it feels like it gets really tight. It feels like it's open. So you stop rotating. What happens then is that your shutoff valve is open just enough that when you go in the cockpit and you look up, you'll say, oh, I have 1,850 psi of oxygen. It's good. But if the pilot takes out the mask where the oxygen is and they push the mask to test, they'll put it on 100% flow and they'll spray a little bit of oxygen out. This will show them that they're getting oxygen flow. If they turn on the microphone, so they can hear it on the speaker, they're testing the microphone and the speaker at the same time. They can hear that the microphone's working on the mask. Also, they should be watching the pressure gauge to watch 1850 psi and watch to see if the needle drops rapidly. If they get any movement. Aircraft that have a digital readout on something called ICAS, on Boeing aircraft, you'll watch the pressure and you'll see. Because some of the aircraft, it might drop 200 psi. Indication. You let go of the mask, you let it sit, it'll come back up to 1850 again. This will tell you that the cylinder is not completely open. So it takes a while for it to fill the line. Once somebody uses the mask, it depletes the line, empties the line. So the problem is if your oxygen bottle is not fully open, your cylinder is not fully open, if there's a fire in the aircraft, the airplane depressurizes, something happens, the pilots put on the mask and they think they're getting 100% oxygen. They might not be getting enough oxygen and they might fall asleep. And the airplane will fly until the fuel runs out and the plane will crash. Does anybody know about Malaysia Airlines 777? Anybody? Malaysia Airlines has a 777 that disappeared over the Indian Ocean. Nobody knows where the airplane is. Anybody hear about this accident? This 777, Boeing 777 just disappeared, Malaysia Airlines? Yes? No? Don't all speak at once. Why is there a recording of the dealing? Let's see, who do we have here? Can you hear me? All right, let's see if we can find this here.
Yes.
You have heard of Malaysia Airlines 777, right? Malaysia Airlines. Plane disappeared. Can anybody see this pretty picture? Ye- You guys should see a picture of a Boeing 737. Can anybody see the picture of a Boeing 737? Yes, no, maybe.
Yes, can see.
Okay. Maybe some of you have heard of this. This airplane was flying in Greece. The airplane did not pressurize. So in this case, then, that means that in the back of the cabin, passenger masks at 14,000 feet, barometric pressure, oxygen masks will fall down. The passengers take the masks, they put them on. But the pilots in the cockpit, not known if they bothered to try to put their masks on because they didn't recognize the fact that the airplane did not pressurize. So as the airplane starts going up through, they started to fall asleep pretty early, maybe as early as 12,000 feet. The pilots started to lose consciousness. Definitely by 16,000 feet, they were asleep. So the aircraft would have been on autopilot, would have climbed up, leveled out, and continued on its course. But the aircraft disconnected, autopilot disconnected, and then the airplane drifted for a long period of time until it ran out of fuel and crashed. So the reason that this may have happened is because of this oxygen bottle situation. So if you're going to install a bottle in the airplane, still a cylinder, oxygen cylinder, you want to make sure that you go through the complete number of revolutions. So your steel cylinder is fully open at approximately 6.5 revolutions. On your composite cylinders, it could be 4.5, 4.25, or 6.5 revolutions. I'll tell you what happens is that on the steel cylinder, you rotate it, and when it's fully open, you cannot turn the knob anymore on the bottle. It stops turning. Composite bottles, you'll feel it open and then get tight. And if you keep forcing it, it starts turning again, starts spinning more, and then finally it hits the point where it's fully open. So unfortunately, if you don't pay attention to this, the difference is between our 6.5 revolutions, 4.25 revolutions, you might put a cylinder in the airplane and think it's fully open, and it's not. And then if your pilots use the oxygen in flight, and that's their main source of staying awake, they'll pass out, and then your airplane will crash and everybody will die. So you want to make sure that you get your oxygen cylinder fully open if you're going to service crew oxygen. Servicing in a Boeing manual. You notice this is page 301. Within 12.15.21, this tells you how to service crew oxygen. Servicing tasks are covered in page block 301 of your maintenance manuals. If it was a description of the oxygen system, it would be page block 201 of your maintenance manual. If you're cleaning and painting, I think that's 700. So you have to make sure not only do you have the correct ATA section, chapter, section, and subsection, you want to make sure you have the same page block that you're for the information. You want to watch your revision date. This is the date that this particular page was written. This is fairly recent, June 15th of 2017. I think actually this manual that it came out of, this would have been a page that was revised fairly recently, but looking at here, there's no R, letter R in the side. So this one was not revised in 2017, that paragraph. Let's see if there's any R's anywhere, anything that was revised. Your forward cargo pit is where you'll find your oxygen cylinder. If you go through the forward cargo door, turn right up towards the cockpit, you have panels here. You remove this one panel that's at the bottom, held on by annoying fasteners called cam locks. They're supposed to be quick release. Not really a screw, but something that you can get this panel off quickly. And we go to put the panel back on again and make it a little bit quicker. If it was screws, it might take you quite a long time to get this on. And then you have your oxygen cylinder here. This is your main aircraft battery. Main aircraft batteries sometimes catch fire, by the way. You can have a thermal runaway and the main aircraft battery can catch fire. So naturally, they put the oxygen cylinder right next to the main aircraft battery. Does oxygen burn? Anybody? Does oxygen burn? If we have oxygen and we have a match, does oxygen burn? And the correct answer is oxygen supports combustion. So if oxygen comes into contact with a combustible material, there's a source of ignition, you can have a very fast, very hot fire. You also have other chemical compounds that if oxygen comes into contact with it, and certain elements, if you have these elements in their raw form, sodium, like in your sodium chloride, if you had metallic sodium, pure metallic sodium, if that comes into contact with oxygen, it spontaneously just explodes, catches fire instantaneously, and it's a very fast and hot fire, which is why you're never going to go to the store and just buy metallic sodium. If you buy metallic sodium, it would be in a dark glass jar like this, and it'd be submerged in oil so that the sodium is isolated from oxygen. You take sodium out, you have to slice up a bit and piece for it for a lab experiment. You have to be very careful because it can catch fire rather quickly. So sodium in its natural state is reacts very rapidly with oxygen. And oxygen itself does not burn, but it supports combustion. So you have to be careful with oxygen because if you come into contact with any grease, you can have a fire. In Kazakhstan recently, there was a 737 that was destroyed. The only way that this could have happened, an oxygen fire, is he got some grease on these fittings. As he opened the cylinder up, the oxygen came into contact with the grease and would have caused a fire. Destroyed the airplane. The mechanic got out of the cargo pit okay, but the airplane, it burnt holes all the way through the fuselage and the top of the aircraft. Difference in weight between cylinders is 15 pounds. So if for some reason you had a steel cylinder and you had to change the cylinder and you didn't have another steel cylinder, if you had damage on your original cylinder and you couldn't service it, or if you don't have servicing capabilities, if for some reason you have to put a composite cylinder in the aircraft or vice versa, you change it, 15-pound difference requires that you do a weight and balance chart revision. Even though you can throw hundreds of pounds of cargo in the front pit, front cargo bay, still something as simple as 15 pounds difference, you have to do a different weight and balance chart for the airplane. And your dispatch your dispatchers, your flight operation officers would be handling something like that for you. You'd have to notify them. This is what your oxygen mask looks like. It stays inside an oxygen box. So you pull this mask out. You can do a press to test. You can listen for oxygen flow. You put it on 100%, you do the test, it'll flow even faster. This verifies that you're getting flow of oxygen to the mask. You can also check your microphone at the same time that way. but you should watch the pressure gauge because any considerable drop in pressure on your indicated pressure on your mechanical indicator on the 737 or digital indication on the A320, any rapid drop in pressure indicated, especially if that comes back again to the normal reading, it will indicate that your oxygen cylinder is not fully open. Some pilots like to get in and hold this for a whole 10 seconds to watch to see if the pressure drops. This, of course, means you're going to have to service the oxygen again more frequently, but it's the captain's decision. If he wants to sit and waste oxygen to make sure that he's got his bottle open, that's their. They've got some kind of a letter. At Continental, they had a letter that said that they should do that. And unfortunately, it means that sometimes aircraft that were within limits for the service check had enough oxygen for dispatch. After the pilots do this test, now they have to call us out and we have to go and service the oxygen. Then that takes 45 minutes. When you tell the pilots that they're going to have to sit and wait for you for 45 minutes, sometimes they get upset. But there's nothing you can do about it because you cannot service the oxygen bottle rapidly. When you take the cylinder out, there's equipment that will service it, will slow down the rate of transfer of oxygen. So you don't end up compressing the oxygen very quickly, end up with a raise in temperature, and end up with explosion. So we have to share another document so you guys can see the sharing. Something else for you to look at. So going back to our Airbus A320, this one is A318, 319, A320, A321. Down here at the bottom, it says XYZ. So this is a fake code. This is usually going to be whatever airline you're working for. For example, TII, THS, CAT, UAL. This manual originally, before I modified it, might actually have been AirAsia Malaysia. I think it said AES, Alpha Echo Sierra, and that might have been AirAsia Malaysia, but I don't know the original owner of this manual. I found it online somewhere and downloaded it. In the manual, you'll have warnings, cautions, and things that say note. Warning: point the overflow drain hose into a container where when you collect the oil, when you connect the hose to the overflow drain half coupling, this will prevent burns from the hot oil spray. Hot oil can cause burns to the skin. Sometimes you can get just the hose and hook it up to your integral drive generator. If you have a hose without a collecting bottle attached to it, then it can spray all over the place, and you would not want to get this oil into your eyes, nose, lungs, mouth. Warnings are things that can cause injury or death. So if you're depressurizing the IDG case, you want to make sure that you don't hurt yourself. A caution: caution, do not use devices other than approved overflow drain hose fittings. Hard metal objects, such as screwdrivers, can damage the overflow drain half coupling seat. My first technician, lead technician I worked for at Continental, used to use a screwdriver to do this particular task. And when I subsequently went to American Airlines for an interview, they asked about servicing IDGs, and I said that you would use a screwdriver to relieve the pressure on the IDG case, and that was a negative point. I did not get hired because my lead technician had taught me how to do this task incorrectly without the proper tooling. He claimed that we didn't have the tool at LAX, but I guarantee we would have had that tool in stock somewhere. Something that says note. These are steps in a maintenance manual that you should follow because it will make your task easier or lessen the chance of having any kind of damage or injury. So warning is the most important thing to watch. Caution is second most important, and note is third most important in terms of things that in a maintenance manual that they really want you to watch out for when you're doing your work. Is anybody there? And anybody say 16,000 baht? 16,000 baht. Check, check. 16,000 baht. Nobody there?
And I can see the manual.
I'm getting you guys another manual. How about
Yes.
16,000 baht? 16,000 baht. Can anybody say 16,000 baht? This is why we study. We study because we want to make 16,000 baht a day. So our definition of terms, if you can see this. So warning calls attention to the use of material, processes, methods, procedures, or limits which must be followed precisely to avoid injury or death to persons. When we go to work, we do not want to die. We do not want to get killed. I worked at 2 locations, San Antonio and Newark, where coworkers of mine were killed. One was killed by an aircraft. It was killed by an RB-211, just like what we have down here. Cut him in half. Didn't hurt the airplane at all. Another person got killed by a ramp tug. He was working and he hit a micro switch and the wheel centered back to the neutral position, and that killed him also. So we want to follow our warnings. Warnings. We do not want to become injured or dead. Incidentally, the 757 that killed the technician in San Antonio that I worked with, that was the second time that airplane had killed somebody. It was with an airline called America West. They're now part of Delta Airlines. So somewhere at Delta Airlines, they have a 757 which killed people on 2 separate occasions. Caution calls attention to methods and procedures which must be followed to avoid damage to equipment. Warning can kill you. Caution can cause lots of damage to the airplane and get you fired. A note probably just makes your life a little bit easier. Calls attention to methods which make the job easier or provide supplementary or explanatory information. This manual is from 2007. The R's means what? Pirates of the Caribbean? R, matey, R. Anybody know what R is? Revision. This R for this paragraph 12, this is most likely that the text within this paragraph, something has changed. In regards to this paragraph here, this entire section right here, the R probably indicates that this is a brand new paragraph, something that didn't exist before, because there's R's next to every line. General recommendations related to the risk of human error during maintenance. Airbus recommends that operators do not do maintenance on different engines or redundant components installed on the same aircraft at the same time, unless it is not possible to do it differently. This shouldn't say that unless it is not possible to do it differently. It should say that operators should not do maintenance on different engines or on different components of the same type at the same time. So you don't look at the magnetic oil chip detectors on all three engines at the same time. Anybody who's awake, what kind of engine do we have in the Rolls-Royce hangar? Anybody? Testing, testing. What kind of engine?
211 turbofan.
And that is from a Lockheed L-1011 aircraft. L-1011.
Maybe Tupolev 204.
Oh, but in this case, this engine is from Lockheed L-1011, and an airline called Eastern Airlines had these beautiful engines on their airplane, and they had one technician remove and inspect the magnetic oil chip detectors from all three engines. And he forgot to put the O-rings back on the magnetic oil chip detectors on all three Rolls-Royce RB211s on an L-1011 that then left and went for a flight over the Atlantic and lost all of the engine oil out of all three engines. Somehow, the pilots managed to keep restarting the engines because the engines eventually would stop running, and they managed to fight with it, and they managed to keep at least one engine running at all times and got back to land safely, but they may not have made it otherwise. But I worked at General Electric. We had one engine that lost oil over the Atlantic, and the pilot did not shut that one down. And it ran for 2 hours with no oil, and that engine actually was in fairly good condition. The bearings were scrapped, but the bearings themselves still spun freely, no binding, no problems. But they had heat discoloration. You could tell they'd been overheated. So, you do not want to perform the same type of work on both engines, 737, A320. There was one night they had me change fuel filters on both engines on one 737 at Continental, and that was very surprising because that's not supposed to happen. In the event that they do maintenance on both engines, different people should do the maintenance. Separate mechanic, separate inspector on each engine. That way the same person's not making the mistake on three engines. But in the end, it's better to just schedule any kind of significant engine work, schedule just one engine today, the next engine, do it tomorrow. It should never be in a situation that they do heavy amounts of engine work on both engines at the same time, because then you have less risk of having an engine shut down and leaving you with another engine that can't carry the load. So they say, if necessary to do maintenance on more than one engine or on redundant components at the same time, different maintenance teams do the work on each engine or component. But at the same time, why schedule it so that you work on the same type of work on number one engine and number two engine at the same time? You should just plan your work so you don't do it all at the same time. That way, if there's a mistake or a problem with your materials or processes or tooling, you don't end up with no engine. Functional item numbers, FIN. On Airbus A320, they use functional item number, FIN. So for an example, this particular component, they say 14CA1. So that is going to be some kind of an electrical component. And here it appears it's an auto thrust system 1. We could take this number 14CA1 and we could search in the illustrated parts catalog, the wiring diagram manual, system schematic manual, aircraft maintenance manual. Every manual will use the same number, 14CA1. It helps to be able to do keyword searches throughout multiple documents. And with the way most of these programs are set up, you could search for this keyword. And just like searching on the internet, it will suggest every time that it shows up within the entire maintenance manual system, whether you're in structural repair manual, troubleshooting manual, so on and so forth. Let me see. It seems we have lost my manual again here. How's this? This works better? See, one of the shortcomings of this thing is I cannot see what I'm projecting. So if you guys don't see the maintenance manual, or you can't, you need a different picture, please let me know, because I have no idea if you can hear me or if you can see anything that I'm looking at. So this one here about the human error, like I said, this paragraph, there's R's next to every single line. And in this case, I think that the revision on this page was that the entire section got added because human factors was not important when they designed Airbus or Boeing originally. It's something that has come more recently. So our functional item numbers, FIN. This is that example one for CA1. You'll find this number is used everywhere within the manual system. Abbreviations in Airbus, you'd also find them in the introduction section in 00. Airbus loves abbreviations. So you have pages and pages of abbreviations. You probably will memorize some of these, but if you can't remember them, this is where you would go back if you're looking in the AMM. And it keeps mentioning things like FPA. You don't know what that is. You come here, you can see that means flight path angle. And of course, unless you're a pilot, you probably won't know what flight path angle is either. Elsewhere. Aircraft in clean configuration. We determined that Airbus considers clean configuration to be that the flaps are at 0, which means also your flight spoilers on the top of the wing would be stowed. So in our page block breakdown of the manuals, if you want to work on a hydraulic system, your page block, lower right-hand corner of your maintenance manuals, if the pages are numbered from 1 to 99, that means it's just description and operation. In Boeing, this would be page block 201. Now in Airbus, though, they go with maintenance practices on page block 201. So actually working on the airplane, let's say jacking the aircraft, applying electrical power, installation of safety devices. Servicing, page block 301. Removal and installation, page block 401. If they run out of pages, which you'll see eventually in engine inspection, bore scope inspection, it's more than 100 pages. They'll add a letter. So they'll still use numbers that would fall within this range, and then they just add a letter. I think they add the letter A before the page. So you end up with page A401 through page A499. Deactivation and reactivation. There's a section here, deactivation and reactivation. The deactivation procedures describe the procedures to be performed to allow flight operations with a system or part of the system failed. So you have, for example, 3 autopilots. You can fly with 1 inoperative. The other 2 have to operate. So then things like this would be covered in the minimum equipment list, MEL, or CDL, configuration deviation list. They say MMEL because people like the FAA will have a master minimum equipment list. Most likely you guys will work at big enough airlines that you will just have a minimum equipment list. It won't be considered master because you're not using the FAA's or EASA's version of the MEL. You'd be using your own airline's version of the MEL, which has the same information, but will maybe look completely different. You might even have a digital version, whereas the FAA may only put out a PDF or a paper version. So you might deactivate some things to fly with a system that's not operating, and then later you will have to reactivate it. Example of this would be like a thrust reverser. I'm sure you guys have heard about the 767 that crashed in Thailand. It had a thrust reverser deploy in flight. This causes one engine to be producing forward thrust. The other engine was producing reverse thrust. The aircraft suffered structural failure in flight, disintegrated. The thrust reverser that had deployed should have been deactivated and locked closed, but it was not. It would have been much safer just to do a deactivation per MEL. Somebody actually disassembled the directional control valve, tried to fix it, and then reassembled it. You do not disassemble hydraulic components on the ramp, try to fix things, and then put it back together. That should be done at a repair station that has authorization, tooling, training, and supplies to be able to disassemble and reassemble hydraulic components. It's not like the T6, we just pull it apart and try to fix it because it's experimental category. So your adjustment tests will be covered in Airbus on page block 501. Further defines that you have an operational test required to ascertain that a system or unit is operational. Functional test, ascertain that a system or unit is functioning in all aspects and according with the minimum acceptance criteria. And you have system tests, contains all adjustment specifications and tolerances required to maintain the system. So they have different levels of tests. Inspection and check. If it says it's a general inspection, basically you're just looking at the aircraft to see if the airplane is in one piece. You're not using magnifying glasses. You're not using eddy current machines. You're not doing detailed inspection. You're just doing a general inspection. The airplane flew in. Will it fly back out again? But then if you do a detailed inspection, then you're looking for specific items, installation, or assemblies to detect damage, failure, or irregularity. You're trying to do a much more thorough inspection. You're trying to find trouble. General inspection, you just want to walk around the airplane and make sure that the wings are still there, the engines are still there, no big puddles underneath the airplane. You're not looking for trouble. Detailed inspection, you're starting to look for trouble. General visual inspection is what you would do maybe on an overnight check. Nothing too carried away. You're not going out trying to look at every single part of the airplane with a 10 power magnifying glass, look for cracks or anything. You're just looking for obvious damage, like a bird strike or maybe a truck ran into the airplane. Special detailed inspection, this is where you do something like we did with eddy current, where you're really trying very hard to detect problems. You're looking for trouble. You schedule the airplane to be in a hangar so that it's somewhere where you can do the work. You're doing a borescope on an inspection. This is special detailed inspection. You're trying to detect some damage. Cleaning and painting is in page block 701 of your manual. So if you want to clean and paint, you'd be looking in an area like that. So we'll look at some specific examples. I'll get you guys another manual to look at. Okie dokie. So here is an example of a more special inspection. This is a bird or hail strike inspection. You notice that with this chapter, they're putting in two completely different concepts into one ATA reference. So 055118, it's covering bird strikes and it's covering hail strikes. In reality, in the big world, these really should be completely separate tasks. They shouldn't be put in the same breath because they really are quite different inspections for different types of damage. But for whatever reason, commercial airplanes at the airlines, almost every airline manual will have bird and hail strike conditional inspections all listed as one task. But you'll notice, well, here they use a separate task number, 055118 210 801. Later on for hail, they'll hail damage. They have a different task number. So it says here, if your bird or hail struck the nose radome, the inside of the radome must be inspected, even if no damage is found on the exterior of the nose radome. So here at the start of this task, they say you only have to check the inside of the radome if you found damage on the exterior of the radome. They contradict themselves because later on they say you have to look at the inside of the radome anyway. Here they say the external and internal areas of the radome in this subtask. You notice that they say if evidence of bird remains or structural damage are found. However, the way this is worded, they do not say that this bird remain or structural damage is found on the radome. So sometimes it gets interpreted by the FAA that you should have looked at the inside of the radome, even though the bird strike was on the wing. So the reason why this is kind of important is if you manage to get the screws out of the radome and get the radome open, when you go to close the radome again, you lower this entire fairing down into position and you try to line up the holes in the radome with nut plates so you can install some screws. And it's very difficult to get a 737 radome closed and get the screws put in and torqued. So it might take you an hour and a half when it only took you 5 or 6 minutes to open it. It might take an hour and a half to get it closed again. You might have to have people sit on top of the radome to put some pressure on it to try to push it to get it to where you can get fasteners in and close that area off. Shut off the radome and install the screws. Another trick that the FAA can have is they can say that you did not inspect the engines when you sign it off in the logbook. They'll say, oh, you did the bird strike inspection, but did you really inspect the engines? Because there's a separate bird strike task here, 710000800802-F00. This is a specific inspection task for just the engine itself. You'll notice that they use the ATA for power plant, 7100. If you have to do a borescope inspection inside the engine, that's going to be an ATA 7200. So sometimes things you're working on on the engine. Some things will be in 71, power plant. Other things will be in 72, engine, depending on different manufacturers where they think the information belongs. They're putting the bird strike in ATA 71 because this can include damage to your cowlings, your thrust reverser, sleeves, and the core engine itself. So there actually is another reference that could apply to bird strikes that's in ATA 72. So your log page write-up might end up having to include 055118, 710000, and then 72-0000. The 800 indicates page block 800, and this would be inspections and checks. Not very exciting stuff, but if you understand how the books are laid out, it makes it quicker and easier for you to find information in a hurry. That way, if you get a pilot who writes something up that you don't have any experience on, you'll be able to find the information pretty quickly. The newer Boeing manuals have the addition of some colors. We have a little bit of red here and this box to draw attention to the warning in bold text, slightly larger font than the rest. Do the deactivation procedure for the leading edge flaps and slats. The flaps and slats move quickly. Injuries to personnel and damage to equipment can occur. They're asking you to deactivate the flaps and slats to do a bird strike inspection. This is a bit of a lengthy process. It involves installing some blocks and some hydraulic selector valves and other things, pulling circuit breakers. It takes a while to do this and document it, and quite often people will skip that, but then the FAA will have trucks on the airport with video cameras. They'll videotape people performing the work, and then they take them in an office later and they say, can you show us where? Show me where on this video you did this procedure. And then when you say, sorry, sir, I didn't do it, then they give you a maintenance violation, try to suspend your license or just give you a warning. This subtask is say do visual inspections of certain areas here. They say the nose radome, and it becomes a matter of debate and confusion. Do you have to look at the inside of the radome or the outside only? If you have a question like that somewhere and you've got the manual with you, you have to read very carefully within all of your subtasks and your tasks to try to figure out that's a subtask. To figure out, does that particular information apply? So in this case now, that particular part of that reference was not in the bird strike, it was in the hail strike, and it was under this particular task, hail on the ground conditional inspection. Okay, I'll get you guys another manual to look at. Is everybody having fun? Just think, 16,000 baht. 16,000 baht. So fuel servicing, ATA 12 for fuel, aircraft fuel, ATA 12. Normally fuel is in ATA 28. Chapter 28 is fuel. So if you're going to work on fuel pumps or anything else, you'll notice here, fueling receptacle installation 282111. Fueling receptacle removal 2821. If I want to see something more about this system, I can refer to 2821 to get a better idea of how the fueling system is working. They also mentioned some things here with ATA 49 APU. And these references are in here because of safety. Some airlines will say if you're fueling an aircraft, if the fuel truck is already connected to the airplane and transferring fuel, you're either adding the fuel or removing the fuel from the aircraft, you might not be allowed to start your APU if the fuel truck is present. Depends on your airline, individual airlines' safety policies. They might say you cannot start the APU or do certain things while fuel truck is there. You also should never run your APU within 50 feet of another aircraft, of the another aircraft's wingtip. The reason is that there are fuel vents, rather large fuel vents, about this big across. You can have fuel vapors there, and if the APU is running within 50 feet, you could cause an explosion in an aircraft that's parked next to you. So you have to be very conscious of what your APU is pointing at when you start it. But in the case of aircraft fueling, you have to be careful with fueling and defueling. So here they have the precaution, APU operations during refueling and defueling. You can shut the APU down during the refueling operation. But it says, warning. Warning means you might get killed. You might blow the airplane up. If there is a protective automatic shutdown of the APU or a failure to start, do not try to start the APU again during the refueling operation. Injury to persons or damage to equipment can occur. This statement didn't exist back when I was working on 737, so that means that somewhere before February 15th of 2015, this was added to the AMM, probably because somebody caused an explosion fueling an airplane by trying to start an APU that was having trouble. Protective automatic shutdown. The APU has a control box that's located in the aft cargo pit of the 737-800. If it senses certain parameters, it will shut the APU down. If your APU shuts down and that was your only source of electrical power, you will start hearing a loud horn that's sounding in the nose gear of the 737, and that warns people that the aircraft is on battery power only and your batteries are going to go dead. This usually happens if your inertial reference system is aligned and it ends up only on battery power, then you'll have this very loud horn that goes off. You hear that horn, you should get up in the cockpit and shut off your aircraft battery. So when I go fly in 747s, the civilian airplane, we have military personnel with a truck. They are not going to fuel the aircraft. I will have to attach the hose to the airplane. I will have to operate the fueling panel. I will have to fill the aircraft. All he does is he turns his pumps on his truck on to provide pressure, and that's it. Everything else, the mechanic, civilian mechanic does the fueling. So 747, I'll have to go to ATA 12, probably ATA 1211. Somewhere in that page range, there'll be something that will tell me how to fuel a 747-400. Interestingly enough, fuel tank defueling, removing fuel from the aircraft, is not covered under ATA 12 servicing. Separate maintenance procedure in ATA 28, 2600, 650-501 tells you how to take all of the fuel that's in the airplane and turn on the pumps, put the fuel back into the fuel truck, mostly because you're going to do maintenance inside the fuel tank. But also it could be that the fuel truck came out and it filled the airplane up for a certain flight, and maybe the flight has changed, the airplane's swapped, and now it doesn't need to have all of this fuel, and they want to remove some of it because then you'll have better efficiency for the aircraft. Might climb faster, carry more cargo, more passengers. So if you're going to do defueling operations, then you have to go to ATA 28 for that. ATA 12 is only for putting the fuel into the airplane, but not for draining it. Any questions? So if you're going to defuel the aircraft, you will run the aircraft hydraulic pumps. There are 2 electric pumps for the center tank. There are 2 separate switches. You can turn both of them on. You can turn the left one on. You can turn the right one on. When you get below 1,000 pounds, you'll have a warning light come on showing that you have low pressure in the fuel pump. This can be rather disconcerting, can make you very nervous having this light, warning light on. You might think that you might have an explosion. Does anybody know that a 737 exploded here in Bangkok? Killed 1 flight attendant. Right up the road from here, 737 exploded, blew up. Anybody hear about that? Anybody here?
In Don Mueang.
Yeah, 737 exploded. Center fuel tank blew up. I'm sure you guys have seen this. So, of course, everybody automatically assumes, oh, it was a bomb because the Prime Minister was supposed to go flying. FBI sent out experts, NTSB sent out experts because they assisted in looking for any evidence that there was explosives used. And it wasn't explosives. So then now you have to look at the design of the aircraft. Why did this happen? Why did we have an airplane bomb? Could it happen again? Scary thing with 737s is, yes, it can happen again. The most boring thing you'll ever read, promise you, you'll never find anything more boring to read than this page. This is the most boring page in all of Boeing manuals. It makes Boeing boring. But CDCCL, remember that. Maybe you don't remember that it means critical design configuration control limitations. As an English sentence, English teacher, this makes no sense. It makes no sense. Who knows what they're trying to say? It doesn't make good grammatical sense. Airworthiness limitation instructions, that makes good grammatical sense. ALI. So you'll see ALI and you'll see CDCCL in the manuals. Maybe you guys have heard of EWIS. EWIS. For EASA, you have to study EWIS. They may not mention EZAP, Enhanced Zonal Analysis Procedure. Again, another term that doesn't make much sense. Electrical Wiring Interconnection System, EWIS. Fair enough. You guys have to study about the fact that EWIS exists. It is defined in 14 CFR section 251701, which for us American licensed mechanics, Title 14, Code of Federal Regulations, section, that should be a capital S, 25.1701, very boring stuff, but it talks about electrical wiring interconnect systems. We want to make sure our wire, power feeder, wiring device, or a combination of these, blah, 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 for the purpose of transmitting electrical signals. We want to make sure that they're in good condition. We want to check our wires for degradation, chafing of tubing, loose duct supports, damage to wiring and connections. Here's another thing too, MSG-3 analysis. I guarantee none of you have ever heard of MSG-3. This is called Maintenance Steering Group. And it's like the third version of this. These are people from major airlines, from high up in their engineering offices, and then government officials. They get together and they decide how frequently an aircraft would require an overhaul or maintenance or replacement of a component, how many hours and cycles on engines, and MSG-3, they're the ones that oversee how maintenance is performed on the aircraft, what legally has to be done. They're really focused mostly on things that could cause loss of an aircraft, injury to personnel, explosions. So EWIS partly addresses things like our explosion of our fuel tank and this enhanced zonal analysis procedure, EZAP and EWIS, because they cover things in aircraft wiring, aircraft systems. So if you see EZAP or EWIS, it can apply to anything on the aircraft with a wire, but when you see CDCCL or ALI, these two terms only apply to fuel system electrical components and wiring, grounding of a fuel system, things that can cause a source of ignition, cause loss of the airplane through a fire or explosion. If you have steps in your maintenance task, if you have 5 different steps, each one will be a separate subtask, and they say CDCCL. From bad experience with the American FAA, you need to have a separate log page. Even though you said removed and installed 767 APU fuel shutoff valve in accordance with maintenance manual such and such, you need to have about 4 or 5 separate log pages to say this subtask where it said to do this specific CDCCL subtask, we did this, and the resistance was this many milliohms. We did this, okay. We made like 5 different log pages to change, remove, and install one component. It was pretty ridiculous the amount of documentation we did. And then the FAA inspector was upset, and he picked on something else because he had to find something wrong. So if you see CDCCL, these items will be most often, almost every single time you see this. This is not a task that you can do by yourself and sign off only by yourself. You're going to need to have quality control inspectors come over. They're going to have to countersign that this task was done and that it met QA, QC standards. And we did that on the 767 that I worked on in particular. But be careful. If you see this stupid thing, CDCCL or ALI, in the fuel system task card, the steps are mandatory, very, very critical, and they don't want to have any resistance between components. So if you install a fuel component, basically you need to have infinite conductivity between that component and the aircraft structure. If you have any resistance at all, then you can end up with a spark jumping in the fuel tank, something that can cause an explosion. And there have been about 11 large-sized Boeing aircraft that have exploded in flight because of fuel tank ignition. So CDCCL, ALI, fuel systems, fuel tank ignition, ignition source. So CDCCL, ALI, those are fuel system. EWIS can be fuel system, but it also could be anything else in the airplane that carries an electrical signal anywhere. Horrifically boring stuff in ATA 05, front matter. Effectivity. This one I left because it's kind of interesting looking, and it's might confuse people a bit, but effectivity. A lot of airlines that will just say all. This one says GOT, all. This is not actually the word got. Like, have you got a glass of milk? Have you got a 737? Here you have the maintenance manual part number D633A101-GOT. The GOT is the code for the airline that this manual is from. I think this is Gol Airlines in Brazil. I think that their code with Boeing is GOT. Continental would be CAL. United Airlines was UAL. You have to make sure with this number here, if you're working in a fleet that you have multiple 737s, make sure you're using the correct airlines manual, because sometimes the text in one manual will not be the same as the contents in another manual. We've got a bunch of discs upstairs, and in 2007, 2008, it was interesting to look at one airline's manual for the 737 and see that it was 13,000 pages. And another airline with the same manual would be only 8,000 pages. So you have to make sure that you have the correct manual for the aircraft and effectivity and your fleet that you're working on as well. So getting back to effectivity, sorry that this is horrifically boring stuff, but basically, since you guys are going to be studying from home, you have to know how you use the manuals so you can do research and find things when I'm not there to help you. So in this effectivity system here, this XYZ is not a real airline. I reiterate, this is a fake airline code. I made this up for our lecture. Boeing has block number, serial number, line number. Usually you might find a data plate in the aircraft with a serial number, block number, line number, serial number. Why they can't just have one number for the airplane, I don't know. Then in the end, your airline will get a registration number. This number right here, that's an American registration. This right here, this CA, there is no country that has CA dash and then 4 letters. No country uses this registration. So you notice it actually says CATC, AP, AQ, so CATC. The fake airline effectivity code I made so we could have an exercise to teach about effectivities. So completely fake registration. But if you need to know your effectivity for an airplane, you look at your airplane's registration, like if we had CATCAP, your effectivity in the manual will be 201. If somebody else is working on CATCAR, his effectivity code is 209 in the manual. Now, if you're working on CATCAT, this airplane right here would be line number 4993. CATCAP would be line number 1024. There's quite a bit of difference in terms of when these airplanes were built, serial number wise. 41268, 32580. So between aircraft 211 and aircraft 201, it's only 10 digits, but you might find out that the airplanes have completely different avionics, different engine models, might be so vastly different that there'd be very little similarity between the airplanes, even if they both look like they're 737-800. There might be a lot of functional differences. The wiring diagrams will look different. So in ATA 05, if you've used a fire extinguisher anywhere on the aircraft, this is probably the most appropriate section to look at. Dry chemical fire extinguisher used. Now, if you use a halon extinguisher or a carbon dioxide extinguisher, so on and so forth, you still want to do some kind of a maintenance task inspection, but you want to make sure that you don't cause extensive corrosion damage to the airplane structure. Chemical extinguishers can cause extensive corrosion damage to airplane structure, electrical system, carbon brakes, and electronic equipment. Carbon brakes in your landing gear. Your brakes can corrode. They get corrosion. When they corrode, they start to crack. And then the discs break and they fall to pieces. And then you have a brake that's not working anymore, and this is not a good thing. You have to be careful looking at your carbon brakes on 737s because a lot of times you cannot see this damage with the wheel installed. So your carbon brakes can corrode. So if you have some kind of a fire extinguishing agent that you use, if you had to use an APU fire bottle, then you would have to do a special cleaning and inspect the area because your fire extinguisher could damage the structure, damage the APU, damage the wiring. So if you're in a 737-800 and you have a fire warning, you're sitting in the captain's chair. Down here, you'll have 3 fire handles, is what they call it. They have lights in them, and it will say that you have a fire in your APU. You'll get a horn that goes off. And then, unfortunately, you only really have a temperature gauge that shows your exhaust gas temperature of the APU. You don't really have anything that monitors and displays the compartment temperature. So if you get a fire indication, you can hit the master caution. You can cancel out the warning. You don't hear the bell anymore. The handle's not lit up. Doesn't seem like you have a fire, but if the light comes on right again, your handle lights up, the bell's going off saying that there's a fire. You have no choice. There's a checklist. You pull the checklist and you say maintenance taxi checklist, APU fire. And it will say, pull the fire handle up, wait 60 seconds. This is very important. If you have an APU fire, wait for 60 seconds. If you use the extinguishing bottle immediately after you pulled the handle up, the APU is still running. Air is still passing through the APU compartment to provide cooling for the APU area. If you have a fire and you fire your fire extinguisher in there and that air is still flowing through, all of the fire extinguishing agent goes out the back and it doesn't always put the fire out. If you don't stop the fire with a fire bottle the first time, you don't have a second fire extinguishing bottle. And we had one airplane at Continental, it destroyed the tail cone, horizontal stabilizer, it damaged the elevators and the rudder because the fire didn't get put out and the fire ran out of control, burned up the tail area, destroyed the APU. Just about 2 months after that happened, I had a fire. I pulled the fire handle up. There's a stopwatch in the cockpit. I started that, watched the second hand go around. When it hit 60, then I rotated the handle and fired the fire bottle. If it was a real fire, it got put out. It also says on the checklist, pull the fire handle, wait 60 seconds, rotate the handle to discharge the bottle. Then it says, call the tower and ask for a fire truck. So I called and I asked for a fire truck. They did not send the fire truck, and but I did what I had to do, and it's on record. It's recorded. If the airplane did have an actual fire, the airplane burned up, at least I did my job. But they basically refused to send a fire truck to the gate, which was not what's supposed to happen. So if you use a dry chemical fire extinguisher for an APU fire, you'd refer to AMM 491100 it says -6. I think something's missing here. But you would want to refer to your AMM for the inspection and cleanup. And again, I also mentioned that this should happen as well. to the management, and at the time they said they weren't worried about it. So I went back, I opened up the APU compartment, did an inspection, tried to clean it as best as I could, but I guarantee it did not get done in accordance with 491100. They would have probably had to have hired a truck to come in to clean the engine and the APU in the compartment. So right now it is 15:48. Do you guys want to keep going or do you want to stop? Do you want more? Or do you want to take a break? Go back to sleep, relax. Anybody? Yes? No? Can anybody hear me?
Yes, I can.
Do you want to finish the class now? Have you had enough fun or do you want 10 more minutes of instruction? I think my battery is going to die anyway, so I think now I will say good night, goodbye. I will see you tomorrow. Have a good day, good luck. Read your manual,
Goodbye, goodbye.
study because maybe you make 16,000 baht a day, every day. Have a good day, good luck. Don't get COVID.